Hello, Mr. Sama again. Welcome to our second video of the lesson of the year. The first video lesson that will be an actual homework assignment that you are supposed to complete and bring into class to show your math teacher. This lesson will be on solving both one-step and two-step equations. We'll deal with these separately. First we'll talk about one-step equations, then two-step equations. To be clear, in class these will also have fractions mixed in with them. We want you to deal with the fractions in class because it's a more complex topic. We're going to deal with things that don't have fractions with them in the video because for most students we expect this as review. We have two learning objectives for the day. First of all, we have a learning objective that you can solve one-step and two-step equations without fractions. This is just that you can do the things from the video, you know how they work, and can complete problems, that's all. Our second objective is that you understand the idea of inverse operations. We will use inverse operations in order to do these skills and solve things. But we want you to understand the idea of inverse operations to the point that you can use them in a mathematical conversation. Which means in class, after you have completed the problems, we want you to be able to turn and talk to the people next to you and talk about inverse operations as you tell them what you did to solve the problem. So first, we're going to just explain how things work, why we solve things the way we do, and we're going to use these two problems to do that. After we talk about why we do things the way we do, we're going to have 4 examples and we'll go through and solve them together. So, good. First problem here. I have -2 plus some number gives us -12, and we have to find out what that number is. Well, many of you that are good at arithmetic probably already know what that number is. The problem is when these equations get really big, we need a framework to do things one step at a time in order to finish them and find out what it is. So, even though I know most of you can solve this in your head, I want you to be able to show your work and go one step at a time so that when they get complex we can do them, we can still complete them even though you can't see the answers in your head. I know my answer is going to be like x equals, and I'm going to have some number over here. That's because I want to find out what x is. So when I have x equals that number, that's my solution. In order to get there, you can see I have my x already in the right place. My problem is this plus -2 stuff. If I could get rid of that, then I would have my answer right there. So we need to get rid of this. How do I get rid of a plus -2? Well, I have to use the inverse operation. The opposite of plus -2 is just plus 2. Some students get confused about this, and they want to say the opposite of plus -2 is minus -2. However, whatever framework you've talked about this in the past, minus negative is the same as plus. If you think back to in class, what do you do when you make something negative with the algebra tiles? Well, you have a positive side up. To make it negative, you flip it over. So if I want to do minus negative, I would flip it over and then flip it back again and be back to the positive side, which is why we have plus 2 here. So I'm going to go plus 2 on this side, plus 2 on this side. -2 plus 2 makes 0. So those cancel out and they go away. On the left-hand side, all I have left is x. Everything else is gone. So good, that's what I wanted to get to. On the right-hand side, I just put these together. -12 plus 2 makes -10. And so x has to be -10. That's our answer. Lastly, I want to make sure I didn't make any mistakes. So to make sure I didn't make any mistakes, I'm going to take my answer and plug it back into the original problem to find out if it works. So, -2 plus x equals -12, and x was -10. Then I just do this. -2 plus -10 makes -12. So that checks out. It works. I know my answer is correct, and I'm absolutely positive that I got 100% on that question, and you should be able to get 100% on this test, because everything you do, you can check. Over here, I'm going to use the exact same type of thing, but my inverse operation is going to look different. With addition and subtraction, the inverse operation is simply the opposite number, and that's it. So negative 2 and positive 2 are opposites. Over here, again, I want to get to x equals and some number. That's when I'll be finished. Well, up here I already have my x in the correct place. I need to get rid of a divide by 4. So what I need is the inverse operation of divide. The inverse operation is multiply. So I'm going to multiply by 4 and multiply by 4. I'm sorry if this is confusing because I wrote over the problem number. Hopefully it's easy to see that because it's in red. I mean 4 times this stuff that we started with. So times 4 and divide by 4 are inverses and they cancel. All that's left is x. Over here I have to do 8 times 4, which gives us 32. And that's it. Lastly, I need to check my answer to make sure things work. So I had x divided by 4 equals 8. X is 32. 32 divided by 4 gives me 8 equals 8, which checks out. Everything works. It's good. We move on. Here are 4 examples that we'll go through together. These should definitely be written in your notebook. So, starting up here, I have n minus 3.8 equals 5.6. I want to get n all alone, so I have to look at what's happening to it. It's being subtracted by 3.8. So the opposite would be plus 3.8. That is my inverse operation. If I add 3.8 on this side, I have to add 3.8 on this side, because these things are equal. If I'm going to maintain that they're equal, I'd better do the same thing to both sides. Negative 3.8 and positive 3.8 cancel and they go away. N is all alone. 5.6 plus 3.8, well, 6 and 8 make 14. And my decimal points lined up, that's the way I'm looking at it. 5 and 3 are 8, and 1 is 9, 9.4. Lastly, I should check my answer. 9.4 minus 3.8 equals 5.6. Well, 9 minus 3 would give me 6, so 6.4 minus 0.8. I am down to 5.6. You could check it. I would do this here, but I'm kind of out of room. It does check. I know my answer is correct, so I'll move on. Number 2. Negative 6 equals k plus negative 6. Again, I'll draw this line. What's the opposite of plus negative 6? Well, again, often students get confused and want to say it's minus negative 6. Minus negative 6 is confusing. So I would rather say the opposite of negative 6 is just plus 6. Do the same thing to both sides. Negative 6 and positive 6 do cancel and go away. So the only thing left on this side is k, and it equals negative 6 plus 6 gives me 0. Also, if you notice, this is the same thing on both sides. Oftentimes students cancel here, and then they get confused about what's left. Well, everything canceled out and went away. So if you had a bunch of things, and I took them all away, you don't have anything left. That's what you have left, is 0. Then I'm going to check my answer again. I started out with negative 6 equals k plus negative 6. K is 0, so I'll put that in here. And this is negative 6 equals 0 plus negative 6 makes negative 6. It checks out. We're good. I know my answer is correct. And so I can move on. Problem number 3. I have m divided by 3 equals 1.5. I need the inverse operation for divided by 3. The inverse operation of divide is multiply. And it's dividing by 3, so I will multiply by 3. Multiply by 3. Divide by 3 and multiply by 3 cancel and go away. M is all alone. 1.5 times 3 gives us 4.5. Lastly, I'll go ahead and check my answer. M divided by 3 equals 1.5. M is 4.5, so I'll put that in here. 4.5 divided by 3 is 1.5. which is equal to 1.5. So my answer is correct, and I can go ahead and move on. Question number 4. 15k equals 75. Sometimes students get confused. They say, well, what is going on here? There isn't even any operation. This is because mathematicians are lazy. Mathematicians early on realized we have 4 operations: addition, subtraction, multiplication, and division. Well, we can pick one of those operations and simply never write it. The operation that we chose to never write is multiplication. You can write multiplication, or you can just leave it out, and we all know that we just assume if nothing is there, it is multiplication. If you're subtracting, you have to write it. If you're adding, you have to write it. If you are dividing, you have to write it. If there's nothing there, it is always multiplication. So, this is 15 times k. The opposite of multiplication, or the inverse of multiplication, is division, and it's multiplying by 15, so I will divide by 15. Divide the other side by 15 as well. Times 15 and divide by 15 cancel, and they go away, and k is all alone. 75 divided by 15 is 5. And so, I have an answer. I just have to check my answer. This is 15k equals 75 was the original problem. K is 5, so I will put it inside there. And I know when there's no operation between these, they are multiplying, always. 15 times 5 gives us 75, which is equal to 75. So this checked out, it works, everything is perfect, and we move on. This is the end of one-step equations, and we'll go on to talk about two-step equations next.